Hello, dear aspirants. This is Dr. Sourav Sir Classes. Our contact number is 98367930076. Again, I am telling our contact number, which is 98367930076. And our email ID is souravsirclasses@gmail.com. So if you have any mathematical queries, doubts, or anything, so please feel free to contact on this number. That means you can call on this number or you can WhatsApp also. Rather, you can drop an email to our email ID, which is written in the screen. Let me zoom it. That will be visible to you. Yeah. So now, I am telling that you, if you can, and you can email to our email ID, which is written in the screen. Then you can join as a student to our institute. And if you have any mathematical doubts, so our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay. So now we are going to solve a problem which is appeared in the CUET PG Statistics, and the question is telling us that the real series summation n equals to 1 to infinity n square minus 1 upon n square plus 1 into x to the power n, where our x is positive, is convergent when we have to find the domain of x. Okay. So what can be done with this? So we are given a real series which is this. Okay, very good. So now we have to determine the convergence of the real series, and also they given that our x is greater than 0. Very good. So what can be done here? So we are going to analyze the convergence. We will use the ratio test, which is a standard tool for determining the radius of convergence of power series. Okay, so now we are going to apply the ratio test. So the ratio test states that for a series which is this, if our limit n tends to infinity, a n plus 1 upon a n, mod of this obviously is equals to L, and then if our L is less than 1, then it is convergent. When it is greater than 1, then it is divergent, and when it is equals to 1, then our this kind of test is inconclusive. Okay, so now what can be done here? So now for a given series, or rather we can say for the given series, the general for the given series, the general term is a n equals to n square minus 1 upon n square plus 1 into x to the power n. Okay, so now we are going to compute the ratio. So let me write with another color. Yeah. So now that will be what? Our a of a n plus 1 upon a n will be now modulus of n plus 1 whole square minus n into n. Sorry, that will be n plus 1 whole square plus n into that will be x to the power n plus 1 into 1 by x to the power n, and here we will have n square plus 1 upon n square minus 1. Okay, so only we will have this thing, and now that will be what? That will be n plus 1 whole square minus n upon that will be n plus 1 whole square plus n into n square plus 1 will remain outside, and our denominator will be n square minus 1 into we will have x. Okay, very good. So now after simplifying these things, we will have that is equals to n square plus 2n upon n square plus 2n plus 2 into that will be n square plus 1 by that will be n square minus 1 into x. So fine, so good. So as n tends to infinity, now what we will have? So now as n tends to infinity, the dominant terms are n square and the denominators and numerators will also have all the things. So if we divide with n square everything, then we will get 1. Then we will have this. Exactly, we will have this thing. So if we put the value as our, or sorry, if we are trying to check the limit at infinity, so we will get all the 1 by n or 1 by n square terms 0. So finally we will only get mod of x here. Okay. So our limit L will be now mod of x. So now we are going to determine the convergence of the ratio test. So if our L is less than 1, the series converges. So the corresponds to this, as we are having L is equals to mod x. So if our x is less than 1, if our mod of x is less than 1, then it is convergent. So our x have to be less than 1. So and our L is greater than 1, then diverges, and our L is equals to 1, then the test will be inconclusive. So now we are going to check the boundary case. That means if we take our x is equals to 1, then what we will get? Then we will get summation n equals to 1 up to infinity n square minus 1 upon n square plus 1, and that will be what? And we all know this thing can be written as n square plus 1 minus 2 by that will be n square plus 1, so that will be 1 minus 2 upon n square plus 1. So as n tends to infinity, this term will go to 0. So the general term behaves like 1. Thus, the series diverges by the divergence test, since the term do not tend to 0. Okay. So the series is convergent when our x is less than 1, and our series diverges when our. So the correct answer of this question will be what? So the correct answer of this question will be our option C. That means convergent if our x is less than 1. Okay, so again I am telling that if you have any other mathematical queries, statistical queries, or doubts or anything, so please feel free to contact us. Then that means you can call on this number, or you can WhatsApp also. Rather, you can drop an email via this mail ID. Then you can enjoy all the services of Dr. Sourav Sir's classes. Okay, thank you guys, hope you understood. Thank you.